Hello. So I'm going to try to answer this question for somebody in my organic chemistry class. So they are wondering, how can you tell the RS configuration for each of the carbons in this molecule? So first of all, you want to figure out which carbons are chiral. And so you would look first at all of the carbons in the benzene ring. That'd be all 6 of these. And each of these only makes bonds to 3 other elements, right? Because this one right here is making a bond to this carbon. Oh, let me change the color. It's making a bond to this carbon, and to one hydrogen. So none of these can be chiral. So they will not be given R or S configurations. Same with this carbon here because it's bonded to oxygen twice and it only makes bonds to 3 other atoms. The carbons over here next to the nitrogen and the ones next to those all aren't chiral either because each of the 2 that are attached to the nitrogen have 2 bonds to hydrogen and the other 2 have 3 bonds to hydrogen. And to be chiral, you have to be bonded to 4 different atoms. So the last carbon that's outside of the ring is this one, but that one also is bonded to 2 hydrogens, so it can't be chiral. So now we're going to look at the cyclopentane ring. If we look at the one that's actually being pointed to in this picture, you can see that it's bonded to this carbon here, this hydrogen, but there's no double bond and there's no formal charge, so it also must be bonded to one more hydrogen. You can draw that in here if you want. And so this one is also not chiral, so it can't be assigned an R or an S configuration. And so the only options are those 2 right there that are highlighted in blue still, that could possibly be chiral. So looking at this first one on the left, it's bonded to a carbon, which is bonded to an NH2. It's bonded to a carbon, which is bonded to this amide group and also this benzene ring. And it's bonded to a carbon that is bonded to these 2 hydrogens. And so, and there's also an implied hydrogen right there. And so it is bonded to 4 different things. So now we have to assign the numbers for each of these things that are around this carbon. So obviously the hydrogen is going to have the lowest priority. So that is going to be number 4. This hydrogen right here is number 4. Then the other 3 options are all carbons, right? All 3 of these are carbons. So we have to look at what these carbons are bonded to. So this carbon right here on the left is also bonded to a nitrogen right here, and it's bonded to 2 hydrogens. What is this carbon bonded to? It's bonded to a carbon, and a carbon. Sorry, I was talking about this carbon right here. It's bonded to this carbon, and this carbon, outside of the one that we're looking at. And lastly, what is this carbon bonded to right here? It's bonded to 2 hydrogens, and it's also bonded to the carbon over here. So each of these. So it's carbon, hydrogen, hydrogen. So we actually don't need to go any steps further because all three of these are different from each other just at this level. So we can see that this one over here on the left is going to have the first priority because it has a nitrogen which is bigger than the carbons. And so this is going to be number 1. Then between the two ones that are left, there's one that's bonded to 3 carbons and there's one that's bonded to a carbon and 2 hydrogens. And so the one that's bonded to 3 carbons is going to have the next priority. So that's going to be this one, and that is number 2, which leaves this carbon to be number 3. I'm going to erase everything except for the 1 through 4 numbers, just to make things easier when we are, I guess I didn't need to erase that, when we are figuring out which way the arrow is going towards. So just again, this is number 1, and then let's put this 2 over here. So we've got 1 on this line, 2 on this line, 3 on this line, and 4 on this line. So that means that the arrow from 1 to 3 goes like this. So at this point you would think that that would be an R configuration because that's the way an R goes, but since the 4 is coming out of the page, it's going to have the opposite configuration. So it's actually going to be an S configuration. So this one is S. So then you'll recall that the only carbon we had left that could be a stereocenter would be this one right here. So we need to figure out what that is bonded to, and it has these 4 substituents. It has this carbon here, this carbon here, this carbon here, and this carbon here. Oh, let's erase this S. Oh wait, no, that S does go there, sorry. Let's just move it out of the way though. Oop, that's not gonna work. Let's just remember that this one is an S. We don't want it to get in the way of our numbering. So all of them are carbons that it's attached to, so there's no automatic numbering that we can do. We have to see what each of these carbons are attached to. So starting at the one on the right bottom, right here, it's attached to oxygen twice because of the double bond to the oxygen, and it's bonded to nitrogen. This carbon on the top right here in the benzene ring is attached to 3 carbons. Obviously, all 4 of these pink highlighted carbons are also attached to the green carbon, but that's not what we're going to count because we're looking for the configuration of that green carbon, so that's not important. We're just looking at the other 3 bonds that the carbons are making. This carbon over here all the way on the left is bonded to a carbon here, a carbon here, and a hydrogen that's implied that comes out of the page right here. So it's CCH. And this last carbon down here at the bottom is attached to 2 hydrogens like we were saying before, along with a carbon on the left. So that's CHH. So yeah, now we have to number, and so the highest priority is going to be this carbon right here, because it has 2 oxygens and a nitrogen, so that's going to be the highest priority. The next one is going to be, so all 3 of these other ones have combinations of carbon and hydrogen, so we're going to look for the one with the most carbons first, and that will be this one that's on the benzene ring, and then this one over here on the left, and then lastly is going to be the one that's attached to 2 hydrogens and a carbon. So this numbering, here, let's erase everything else. Okay, so let's see. Let's remember we're looking at this carbon right here, and let's fix this 3. It goes right here, and this 4 belongs to the carbon right here. Okay, so our 1 through 3 numbering is going to go like that. So that one looks like an S, but again, the 4 is coming more out of the page and the 1 is going back into the page. So let's actually draw this separate to see how it would be rearranged so that the 4 is in the back. So we're going to call this BZ for benzene. That would be this group right here. Instead of R, we're just going to call it BZ to make things easier. Over here, we could call this AM for amide. And then, let's see. Let's call this CH2 and C3. Just to make things easier, obviously these carbons are attached to each other and that makes this whole thing more complicated, but we're just looking at the shape around this carbon right here. And we want this CH2 group to be in the very back, and so let's see, how can we rotate this? We could rotate it coming towards us so that this benzene group will be where the CH2 group used to be. Yeah, basically rotate it around the C3 group. Right, so then the C3 group is going to stay exactly where it is. And then this benzene is going to be down here. And then the CH2 is going to go in the back. And the amide will come out in the front. And then we can see from our numbering over there that the benzene was number 2. Oh, let's see, that's not very distinct. The benzene was number 2. The amide was number 1. The CH2 was number 4. And the C3 was number 3. So then our arrow goes 1, 2, 3. And so it's really not an S configuration at all, it is an R. Because that's now with the 4 in the back. So we go back in here. This one is R. And like we figured out before, the one next to it on the left is S. And so that's how we figure out the stereocenter configuration for each of the carbons in this molecule.